Okay, now let's talk about the next pile of properties. Next pile of properties are odd even functions and cofunctions. Now, the first, if we take a look over here at the odd even functions, we see sine of negative theta equals negative sine theta. So let's deal with that one first. Sine of negative theta equals negative sine of theta. Well, you can't prove things using a specific example, but I can illustrate how it works using a specific example. If I say sine of negative 90, the identity tells us that that's equal to negative whatever the sine of regular 90 is. So let's see if that is true. So first things first, if I take the sine of 90 would be at pi over 2, so that's going to be right here at 1. So it's pi over 2 comma 1. Now, so if 1 is the value here for sine of 90, put a negative out front, negative 1. Let's see if it's true. Sine of negative 90. Well, there's pi, so that's 180. Negative pi over 2 is going to be right here. You go down and lo and behold, negative 1 is the value. It's negative pi over 2 comma negative 1. And so in this case, negative 1 equals negative 1, and it's true. This happens because sine is an odd function. Alright, it's an odd function. So the negative that's inside can come outside. Just like if I took x cubed and I said negative 1 cubed, it's going to equal the same thing as 1 cubed, but times negative 1, because negative, negative, negative means the negative's still going to exist when we're done cubing it. So, that is an example of an odd function. Now let's go over here on the even function side. It says that in this case, cosine, since it's an even function, cosine of negative theta equals cosine of theta. The negative disappears. Just like if I took x squared and I had negative 2 squared, it's going to be 2 squared. The negative disappears because negative times negative is a positive. So, if that's our case, let's go up here and say cosine of theta. Well, let's say 180. So, cosine of 180. That equals negative 1. Cosine of negative 180. Well, cosine negative 180, that's also going to equal negative 1. If I did cosine 90, I get 0. If I say cosine negative 90, that's also 0. So, because it's an even function, the negative is going to disappear. So, odd function up and down, so that means when it goes back, it goes negative first, then positive. It's backwards. Or here, even function, it's nice and pretty and even, so whatever it is here, it is here. Whatever it is here, it is here. As opposed to upside down from one another. Okay? So, even functions and odd functions. Now let's talk about cofunctions. If I have a cofunction, in this case, let's do a cofunction property with sine. So I say sine of theta equals cosine of pi over 2 minus theta. So here we go. Let's say sine of 180. Well, that would mean it's cosine of 90 minus 180, which means I would end up with cosine of negative 90. Well, let's see if sine of 180 equals cosine of negative 90. Sine of 180 is 0. Cosine of negative 90, also 0. So they do match. There are two different spots on the graph, but that's because sine and cosine of the same graph just offset from one another. And so that's where you get this property. Now let's test it again. Let's go a cosine of theta equals sine of pi over 2 minus theta. All right? Now, let's do cosine of 45. Well, cosine of 45 would be the same as sine of 90 minus 45. So here we go, cosine 45 equals sine 45. Well, let's find out. If I have 45 degrees, I have 1 root 2. Cosine is going to be 1 over root 2. Sine is also going to be 1 over root 2. They do match. Now, what really blows the mind is if you have something in the ballpark as follows. Okay? Let's go with cosecant of theta equals 2. Let's find secant of theta minus pi over 2. Now, you say, ooh, I see pi over 2s, and anytime I see pi over 2s, I ought to be thinking cofunction. So let's go to cofunction. We want to find something with a cosecant in it. So the property here is going to be cosecant theta equals secant of pi over 2 minus theta. Now, you say, well, that's easy. So whatever this is. Not quite, because this is theta minus pi over 2. This is pi over 2 minus theta. They don't match. So I cannot just plug this right in for this. Except that I know secant. Secant is an odd or an even function because it's based off cosine. Because based off cosine, it's an even function. And so whatever the negative is inside simply disappears. So if I were to rewrite this secant as secant of -1 times pi over 2 minus theta. Now, I did that by simply taking out a -1 from each piece. But the nice thing is because it's even, secant of theta, this -1 is going to disappear, leaving pi over 2 minus theta. So now I can indeed say that whatever cosecant of theta is 2, that's equal to secant of pi over 2 minus theta, which is also 2, which is equal to secant of theta minus pi over 2, because these two can turn around because it's an even function. So in an even function, those two can switch. In an odd function, you can't make the same statement. So that's a couple even functions, odd functions, and cofunctions, putting them all together to try to make a couple movement in some of the trigonometric identities.